All right, now we want to talk about something very, very important, and that is measures of central tendency. Okay, in brackets, I've also said averages. That's another word for the measures of central tendency. We can call them averages. Now, what are these? What are these measures of central tendency? What are they? Well, these are, if you see here, we said when you have something called a measure of central tendency, then you have a typical value of a set of values. You have a set of values and you want to know what is the typical value, which value is happening, is a typical value. I'll explain to you the different ways we can describe that word typical just now. So when we say we have a typical value, a representative value, then we have a measure of central tendency. It is a value that represents our data in some way. Now, these values here, second line, it says it helps to describe data sets. So we can have an idea of a set of data by using this value. It describes our data in some way. Let me explain to you. When we say we have these measures of central tendency, we said it's a representative value or a typical value. And there are three types. You could have three types of what? Of averages or of measures of central tendency. One could be the mean, or you could have the median, or you could have the mode. These are all averages, or they are all measures of central tendency. Now, what do they describe? If you take something like the median helps you know which value is right at the middle of all that bunch of values. So what you do to know the median is you have to arrange your data in order, smallest to largest, and then you can see which one is at the smallest, which one is at the center. So say I have 30 kgs, 31, 32, 33, and 34. Right now I can see that 32 is right at the center, 2 on the left, 2 on the right. 32 is right in the middle of all these values. So that is what median helps me know. Helps you know the number that is sitting right in the middle. If you arrange your things, then you can see the number which is right in the middle. That's different from mean and mode. Mode tells you the number that is occurring the most. So sometimes we may want to, instead of using all the values, we may want to use the values that is happening the most. Okay, that has the most frequency. For example, we can see the most common type of meat, and we can use that to represent our butchery or whatever. We can see the most common song, then we can use it, or whatever it is. So it is our representative by being the most common. That is mode. Mode is giving you the most common. So it is a representative value. Yes, that's why it's called a measure of central tendency. It's a representative because it is the most common. Okay? What about mean? Because we saw that median is the value that sits right at the center when you arrange. Mode is the most common. What about mean? Mean is a value which, for example, let me show you. Say I have say cars, right? And one car is going for, I'm using dollars here, 1,200. The other one is going for 1,500. And the other one is going for, say, 1,800. Now, or let's say 2,000, right? Should we say 2,200? Now, these are the three cars that I have. And if I sell all of them, right? If I sell all of them, I can have an idea of how much money I will make. It will give me a certain amount of profit. These are different cars, okay? This could be, sorry to use names. Okay, let me not use names. But this could be any car. Whatever these cars are, we can sell them and get different profits. Now, mean, we can take a certain value, right? Say we can take one car. Instead of having three cars that are different, which means we'd have to buy them from different manufacturers to get and then sell them to get a certain profit. We can have a certain car that if we buy three of that type, would give us the same profit as these three. So, in other words, I could have three of a certain value giving me the same answer as these three. Now, how do you get that mean? Okay, so mean is our focus in this video. Mean is a value which, say I have 5 values and these 5 values are different. When I look at their effect, what these 5 things are doing, mean is a certain value in which if you bring 5 guys that are having the same mass, let's say we have 5 guys that are different masses, and when we bring them together, they do a certain job. Now, for mean, we can say instead of being 5 different guys, we can bring guys that are the same, 5 of them, and those 5 will still do the same job as those 5 different ones. So mean is a value that if you bring it in the same amount as the different guys, although it will be the same value, it will do the same effect. Okay, it's not a value that does the same effect alone. No, but if you had 5 different, mean you'd be 5 being the same. You'd need 5 again, but they'll be the same, and those two give you the same effect. So here we said for cars, we can bring 3 cars that have the same price or the same type of car, but we need 3 of them as well, because here we had 3, but they were different. We can bring 3 of the same type and it can give you the same amount of profit. So how do we get this mean? When we want to get the mean, that value that if you bring in the same number of things can give you the same effect, mean would be just, we say, mean is equal to the sum of the things then divided by the total number of things. Okay? The total number of things, right? Total number of things. So if we were to put it in symbol notation, we would say mean, we would say x bar. This would be equal to summation. Sum, you do the sigma. This is a capital sigma. In Greek, small letter sigma is like this. You've seen it. We use it for standard deviation. Then capital sigma is like this. It's an S. That is the S for Greek. Small, capital. Okay? This is the capital sigma, right? This is the capital sigma, and it just means summation, right? This small one, we saw it means standard deviation, right? This small one means standard deviation. So, summation, it means we are adding. Whenever you see this, it means we are adding. What are we adding? X values. So, X will be our data. Whatever the data we add it, then we divide by the total number of things that we have. This would give you the mean. So let's say for here, what would be? We can say our mean x bar would be summation of x over n, right? Now, which means you would then write below to say it will be, what is the summation of x? 1,200 plus the other one, 1,500, because these are the x values, right? Plus the other one, 2,200. So plus 2,200 divided by 3, okay? Then we can be able to find. So what would be the final answer here? Okay, to make it neater, maybe let's say this is 1,250, right? So we would have 1,250, the two values. So one car is 1,250, the other one 1,500, the other one 2,200. So now let's deal with them 3 like this and see.